Problem 17. This is regarding sketching graph of a function. In this case, the function is 5x squared over x squared minus 4. Notice this is a long problem. So I have already gone ahead and filled in all the blanks so as to fit everything in a 15-minute video. Okay. So graphing problems, if you remember, these are long problems and it's very important to understand every single step. Okay. There are many steps to graphing question. I have highlighted all those which are needed to fill this particular problem. But I think it is a good idea now to go to section 3.5 and review that material entirely. All right. So, okay, let's get to business. Fx is 5x squared over x squared minus 4. Okay. To begin with, domain of f. What is the domain? Where is this defined? Look at the denominator. If you factor it, you get x plus 2, x minus 2. So, this gives me negative 2, 0 as a 0, and this gives me positive 2 as a 0. That is, x equals negative 2 and positive 2 will make the denominator 0. So I have to remove those numbers from real number line. So from the real number line, I have removed negative 2 that splits into two intervals, and I have removed positive 2. So this is the domain. Okay. Second step, find the derivative. Well, this is quotient, so quotient rule applies. Square of the denominator, derivative of the top, denominator as it is minus, numerator as it is, derivative of the denominator. Simplify, simplify, simplify. This is what I get. By the way, this particular entire file I will upload so you can check these calculations for yourself when you're working on your own problems. Okay. All right, I found the derivative to be this. What are critical numbers? Critical number, a number C in the domain of f is a critical number if the derivative is 0 or derivative does not exist. Well, this is my derivative here. It does not exist when x is plus minus 2. But these numbers plus minus 2 were not in the domain of f anyway. Remember, f, you had to get rid of plus and minus 2. Okay. So they don't contribute to being critical numbers. So how do I get critical number? Well, the other option is to set derivative to 0 and solve for my x. So I take my derivative to set it to 0. Well, negative here outside, so why don't I get rid of it? How do I get rid of negatives? Well, multiply by negative 1, both sides. Negative goes away, 0 times anything is 0. So, this quantity is equal to 0 over 1. Cross multiply. 40x equals 0 times anything is 0. Solving for x, you need to divide by 40, which gives me x equals 0. So that's the only critical number. So once I have a critical number 0, I use negative 2 and 2 as cut points. They are the points where my function was undefined. Okay. So that gives me how many intervals? 4. 1, 2, 3, 4. In each of these intervals, I choose a test number. Test number negative 3 here, negative 1 here, 1 here, and 3 here. I plug in, substitute these test numbers in my derivative. Okay? I don't care about the final answer. I care about the sign of my derivative at these test numbers. Okay? So keep in mind the minus outside, that is the negative outside. It tends to contribute. Okay? So turns out you can check, or while you do your own problems, be very careful with the signs. These are the signs I have. When derivative is positive, my function is increasing. When derivative is negative, my function is decreasing. So f increases or decreases based on the sign of f prime. Okay, what's the purpose of this? Well, here we go. My first interval I am increasing, second interval I am increasing, third interval I am decreasing, fourth interval I am decreasing. Now these are vertical asymptotes because they were in the denominator. You see, negative 2 and 2 were zeros of the denominator for this particular function. Okay. If you see the denominator, it factors. Correct? And none of these factors cancel with anything above. That is, these factors continue to survive in the denominator even after simplification. In other words, they contribute to vertical asymptotes. Okay? So when x approaches negative 2 from the left or from the right, or 2 from the left or from the right, you're going to get either a positive or a negative infinity. Okay? Which is what it means to say these numbers give you vertical asymptotes. X equals 2 and x equals negative 2 are vertical asymptotes. Well, my function was increasing here, right? We just checked above. Increasing. So it cannot go to negative infinity. It has to go to positive infinity. Likewise here, in the second interval, my function was also increasing, right? So, mind you, it cannot go up like this because we don't read from right to left. We read from left to right. So if I'm increasing, I have to come from negative infinity. So my curve has to rise in this fashion. After 0, here is vertical asymptote. I'm decreasing. So wherever I am, I'm going to negative infinity. After 2, I'm still decreasing. I cannot start below because where else am I going to go? So I have to come from above. So vertical asymptote behaves in this fashion, right? I have to come from above, positive infinity, going down because I am decreasing. So understand the nature of the curve as you approach asymptotes. I hope this is clear. You're increasing on the left, reading, you have to go up. Negative 2 from the right, you have to go down. If you go up, if you draw your curve up here, well, then it's not an increasing function because you read from left to right, you see. I can't draw like this. That would make a decreasing function. So if I'm increasing, I'm coming from bottom here and increasing. All right. So these are my vertical asymptotes, and we understood how the asymptotic behaviors represent here. In other words, limit x approaching negative 2 from the left is positive infinity. Limit x approaching negative 2 from the right is negative infinity. Limit x approaching 2 from the left is negative infinity. Limit x approaching 2 from the right is positive infinity. What about horizontal asymptotes? You get horizontal asymptotes, if any, if limit x approaching plus or minus infinity gives you some number. Ideally, you would look for two different limits, one with the plus, the other with the minus. But in this case, because this is a rational, it's okay to take plus minus infinity at the same time. Rational function. How do I find limits at infinity? I divide by the highest power of x from the denominator. So that's x squared. So divide the numerator by x squared, divide the denominator by x squared. Numerator simplifies to a 5. Denominator x squared, remember division distributes. So this division gives me a 1 minus this division gives me a 4 over x squared. At this point, I can let x go to infinity, plus or minus. Well, this guy, 4 over x squared goes to 0. The others survive. So you have 5 over 1, which is a 5. So right hand limit is y equals 5. Left hand limit is y equals 5.